is that you have to be careful. It's not just force, it's the force in the direction that the object actually moves. So if you imagined that you were pulling a sled across the ground, most of us don't take the time to get down here and get really low to the ground and pull it straight along the ground. Although I think that would be the best way to pull it, wouldn't it? Yeah, you don't want to pull it too much at an angle. But most of us pull up at an angle, and what that does is it gives that force. If here's your box, here is your force, right? That actually gives it two components. These are vectors. This is a vector concept, right? There's a component in the parallel to the direction that the box moves. There's a component perpendicular to the direction it moves. Yeah? Yeah? Okay? And I don't want to get too mathy here, but I think if that's the angle there, right, if that's the force, then this side is the adjacent side, isn't it? So isn't this F cos theta? And this side is F sine theta? I think that's how it works, doesn't it? Now, of those two components, F cos theta and F sine theta, which one is actually doing work? Cosine does work. Why? Because it moves in that direction, right? And the sine doesn't do any work. It doesn't move up unless you lifted the sled up, right? So that's what this is, okay? That's why it's cosine. Now, fast forward, you're taking this class in college, right? They're gonna talk about something called a dot product. They're just gonna say it's F dot D. F dot D just means this. It means the same thing. Take the cosine of the angle between them, twixt their tails, right? So you put them tail to tail, find the angle between them. There it is, right? It's obvious. If they don't give an angle, it's probably 0 degrees, which means it's in the same direction. Cosine of 0 is 1, so you don't need to worry about it, right? And then if they give you an angle, just make sure it's this angle that they're giving you. Find the cosine of it. You're set, right? And then there's another tricky thing. There's another tricky bit, okay? What if I take this mass and I exert a force upward on it? Here, you know I'm exerting a force upward. I hook this thing on there. I'm exerting a force. You see that? The meter's reading something. Is it moving up? No. Did I do any work? No. Biologically, I could become tired or something like that doing this. It's like an isometric exercise. But work is very narrowly defined in physics as a transfer of energy. Have I transferred energy to that mass? No, because I haven't moved it. Yeah? I've got to actually move it to actually do work. So if the distance is 0, the work is 0 because something times 0 is 0, yes? And because we haven't transferred any energy. Both reasons, yes? Okay? Now, the second tricky thing, okay, is this. I'm going to push this thing up. When I push it up, which way is the distance? Up. Which way is the force? Up. Okay, the angle between up and up is 0 degrees. Cosine of 0 is 1. Okay, now watch this. I'm going to take it from there. I'm going to put it there. Now, during that time, which way was the displacement? Which way did it move? It moved down, but which way was the force I exerted on it? The force was up, wasn't it? Yeah, I still exerted a force up. Imagine if I exerted a force down on it that time, right? I'd be slam dunking it into the concrete. I think I did that one time and I actually broke like a floor tile and had to apologize to them. I was like, well, if I push down on it, well, yeah, it slams into the ground really hard. Okay, it's hard to push down on something, right? Okay, so yeah, as I'm moving it down, I'm exerting an upward force on it. So am I transferring energy to this, or is it transferring energy to me? It's actually giving me energy. If I was cleverly built, if I was built like a Prius, as it moved down, I could like generate electricity and store it in a battery and use it later or something. Yeah, right? Okay. Or I could make food. If I was a real human Prius, I could like generate food in my stomach, you know, and then I'd use it later, right? Obviously, we can't do this, right? But as it goes down, right, it's losing energy. So its change in energy is negative. Now, let's go back to the math thing. What's the angle between up and down? It's 180, isn't it? Yes. What's the cosine of 180? Anybody remember this? Negative 1. So that would predict that our work would be negative. Okay. So negative work, just write that down, right? Okay. Negative work is when the force and the distance are in different directions. Okay. We move the mass down. There's our distance. but our force is up, right? That's negative work. The mass does work on us, right? And if we move it up, we do work on the mass. Yeah? So just be careful. I think I'll give you one of those problems and, you know, be like, say it again. So just be careful if they are in different directions, it's negative work. Yeah. Say it again. Negative work is if, or another example of it would be, I push the box this way, but somebody stronger pushes it back toward me, right? I'm pushing that way, but I'm moving backwards. It's when the force and the direction are in different, when the force and the distance are in different directions, opposite directions. Yeah? I think it's time to do some whiteboard. Fred Oda Dark. I have whiteboards over here. If you guys lost your whiteboard under your desk, please let me know. I took them out of these rows because we moved the chairs for the test. You need a whiteboard, sir. You need a whiteboard? You got one. Who else needs a whiteboard? Should I toss it to you? I'm just kidding. I'm going to pass this back to Brandon. Pass that back to Sam. Pass that back to Alex. So what's the name here? What's the name? Fred? What? Fred Oda Dark? I'm Fred Oda Dark. Are you Fred Oda Dark? Thank you for groaning. I'm little Fred Oda Dark. Fred Oda Dark. Fred Oda Dark. I'm doing attendance. Are we all here? I think we're all here. Let us rejoice in this moment.
He doesn't know James means. That's good. Oh, God. Just like that's gone.
The magic triangle is this. Work, force, distance. Yeah, that's right. You got it. This is the only one that's got an angle, so make sure you're not in radians and you should be good. You're going to do the full FD cos theta. And then from here on, we're going to like ignore the angle. Huh? It's in joules. Work is in joules. Newtons. Meters. So a joule is a Newton meter. Yes, yes, yes. I think so. Is that one like 137, 139 or something? I love that. That's good. What are the units? That's right. Yep. Did you get 137? Yeah, that's right, 139. There you go. Yeah. There you go. Yeah. Can we make a triangle that's got like a food pyramid?